Welcome to this trial lecture presentation. The title is Cybersecurity and AI. This topic was given to me by the committee 2 weeks ago. And now the presentation will start off by describing the concepts, providing some definitions and historical background information. The main part of the presentation focuses on findings from the literature review, which I conducted to give you a snapshot about the recent developments in the field. The presentation will finish with summary of key findings and some conclusions. So I assume that by AI, we are interested in artificial intelligence and how it affects cybersecurity. So both of these topics are very popular nowadays, and they have a huge literature base. This presentation focuses on the intersection of these two huge topics. So the dictionary defines cybersecurity as measures taken to protect the computer or computer system against unauthorized access or attack. This is especially relevant for networked computer systems connected to the internet. Cyber and cybernetics means governor or steersman, and the term can be traced back to Norbert Wiener's very influential book called Cybernetics, or Control and Communication in the Animal and the Machine. So this book from 1948 basically established the field of cybernetics, and it described multidisciplinary research results which were interested in how signals propagate in nervous system of animals and how these principles can be implemented in electronic circuits and machines. So how to enable machines human and animal-like control capabilities. So why is cyber domain dangerous? Why do we have to talk about security? Cybersecurity is distinguished from other fields because it always assumes intelligent, motivated adversaries. And unlike other fields, which are mainly interested in some kind of random natural process as generating undesirable consequences, in security there's always some kind of motivated attacker. So Interpol distinguishes between cyber crimes and cyber-enabled crimes, where cyber crimes are high-tech, sophisticated attacks against computer systems, and cyber-enabled crimes are traditional, old-fashioned crimes which migrated to the cyber domain. ENISA, which is the European Union Agency for Cybersecurity, reports the top 15 cyber threats. So describing the threat landscape, it's important to understand what kind of attackers are there, and individuals and organizations are exposed to various adversarial activities. In last year and this year, it seems that malwares were the most prevalent forms of attack, but we can identify familiar terms like phishing, spam, insider threats as well, and some emerging trends like ransomwares, cyber espionage, and cryptojacking. So many attackers and adversarial agents are attracted to the cyberspace, and we have to deal with highly motivated, skilled attackers in most of the cases. Artificial intelligence is defined by the dictionary as a branch of computer science dealing with the simulation of intelligent behavior in computers, or the discipline that aims to imitate intelligent human behavior in machines. One textbook describes the field as consisting of several cognitive functions such as searching, reasoning, planning, and so on, which are generally associated with high-level human behavior. But if we talk about artificial intelligence, it's useful to define what human intelligence is. And there's a saying between psychologists that intelligence is something that an intelligent test measures. This shows that there's no unified, universally accepted definition of intelligence. It's a difficult concept, but when we think about general cognitive ability, which is G in this picture, depending on the level of analysis, it is possible to define between 10 and 70 different broad or narrow abilities which constitute together general intelligence which humans exhibit. The history of artificial intelligence can be traced back to the 50s, especially to a paper by Alan Turing, who gave a serious thought about the possibility of machines that can think in a way that humans do. And he developed his famous Turing test as an imitation game, so that when a machine is capable of human level intelligence, a human interrogator would not be able to differentiate between a human and the machine. Then in 1956, the term AI was coined by John McCarthy at a summer conference, at which conference Alan Newell and Herbert Simon already demonstrated their logic theorist, which was an automated reasoning system. And it shows that the field from the beginning was a multidisciplinary attempt. So researchers from various backgrounds have had different motivations. Some aim to better understand human intelligence by creating models and observing the mistakes these models make. Others were purely interested in simulating or imitating human-like behaviors in machines. So in the picture, we can see several famous milestones which characterize the history of AI, like in 1997 when IBM's Deep Blue conquered the best chess player at that time, Kasparov, and DARPA had a challenge in 2005 where it was demonstrated that self-driving cars are already possible. Then in 2011, IBM's Watson system defeated the best players in a very famous TV show quiz, which required a lot of explicit knowledge and reasoning skills. And then in 2016, AlphaGo defeated the best Go player. And this picture also demonstrates that AI is far from being unified. There are many different approaches, and all these approaches have different philosophical and technical backgrounds, and they all aim at achieving some narrowly defined task for which these various methods can be useful. But the general intelligence which humans exhibit is still the promise of the future, and it still hasn't been achieved by machines. Some interesting concepts related to AI are listed here. One of them is Polanyi's paradox, which is the observations that humans rely on a great deal of tacit or implicit knowledge. which is not accessible to consciousness. We cannot verbalize this kind of knowledge like intuition and sensory motor skills, which makes it very difficult to create certain types of artificial systems imitating these behaviors. Moravec's paradox describes the observation that there are certain tasks which are very difficult for humans, like arithmetics, for example, which are, on the other hand, very easy for computers, and they can be programmed to complete the task without errors easily. On the other hand, certain skills which humans are very good at and perform without effort, like sensory motor tasks, like moving around in the environment and manipulating objects. These are very difficult for artificial systems. AI effect is the phenomenon where if a certain task is successfully achieved by the an AI system, it is no longer regarded as requiring human intelligence. So beating the best chess player seemed to be a impossible task for artificial intelligence. But when it achieved, people started saying that it's pure computation and it doesn't really require that kind of intelligence which humans have. AI winter, that's a period in the history of artificial intelligence when systems failed to meet expectations, which were sometimes exaggerated. At these times, funding and research interest declines in AI. So during the history, AI has seen at least two longer winter periods where funding and research interest declined. However, nowadays, AI definitely sees a huge interest, and people are really interested, and a lot of money is being spent on developments in this area. And this these advances can be attributed to various factors. For example, key components of modern AI systems are the availability of big data sets, which are generated by various sensors and humans as well. Advanced learning algorithms, which can identify patterns in these and analyze these huge data sets, and increasing the computational power, which makes all this possible. So these also are key ingredients of modern AI systems. And Turing's test require at least 4 or 6 skills, which a single system should have in order to complete the test. It's about being able to process natural language, to communicate with the human, to have knowledge representation, be able to reason in an automatic fashion, machine learning to adapt to new circumstances, as well as computer vision and robotics to manipulate its environment. So far, no single machine is able to conduct all these. So in our everyday lives, we can meet AI without being aware of it. Here are some examples. So on the first picture, there's a self-driving cars view and its representation of the world, how it tries to identify various objects, and it makes decisions in real time, which is a huge achievement, but it's computationally very, very intensive. Various companies are creating virtual assistants with which we can have conversations and they can perform certain tasks. Face recognition is also nowadays exists in most cell phones, which is based on advanced pattern recognition. And AI systems can extract features from various pictures and generate new faces, new human faces, which look completely natural to us. But there's also machine translation and recommender systems are all based on the paradigm of big data sets, huge computational resources, and advanced learning algorithms. So there's definitely a huge impact in various domains by AI. And now we're moving on to the literature review. Using a combination of all these words associated with cybersecurity and artificial intelligence would definitely generate a comprehensive review. However, due to restrictions, I relied only on the combination of the two major keywords in this rapid or scoping literature review as defined by the relevant resource. And I used these search terms on the 4 biggest scientific literature databases without restrictions. So anywhere in the text they could have appeared. That's why we can see that the search generated more than 2,700 results, which shows that there's a huge interest in the topics. Most of them were irrelevant for our purposes, since I prioritized recent reviews, surveys, and case studies with high impact case studies. So a high citation number would be an indication of an influential paper. So 17 papers were finally included based on inclusion and exclusion criteria. And this pattern, this huge amount of research work does not really match with Gartner's famous hype cycle, which says that interest in AI and deep learning and machine learning is beyond the peak of inflated expectations, and interest is on the decline. It seems like there is a huge research interest still. So based on the review, it seems like there's 3 main issues which emerged from the review. The first is related to how AI can help cybersecurity to improve defense capabilities. The second issue is about how attackers use AI for their own benefits. So what's happening on the attacker side? The third issue is related to the vulnerabilities of AI systems. In these cases, AI is not used either as defense or as an attack, but it is the target of attacks and malicious activities. And there's a fourth issue which is somewhat related, since AI is being used and adopted in many critical domains. AI systems can show surprising behaviors which are different from the expectations of the developers. So it's important to focus on those issues as well. And this is the fourth issue of AI safety. So the rest of the presentation follows this structure. And first, let's see how cybersecurity can use AI for its defense purposes. So most papers which were included agree that there's a huge need in cybersecurity to improve their capabilities, and AI can be a promising method since it has demonstrated such huge positive impact in other domains. And the complexity of systems and static defense mechanisms are no longer sufficient when adversaries are evolving quickly and are becoming more and more sophisticated, and the sheer amount of data that needs to be analyzed and managed is beyond human capabilities. So humans are losing in this kind of race. Another factor is that the introduction of IoT devices complicates the landscape, threat landscape as well. New vulnerabilities are obviously introduced by huge amount of IoT devices, which cannot be handled with traditional methods. There's also a huge monetary incentive for developing AI. It's been predicted that by 2025, AI-based security will generate more than $30 billion worldwide. Obviously, if AI can live up to the expectations and it is able to improve safety, system robustness, response, and resilience. And there's a need for flexible real-time threat detection capabilities. And AI is supposed to be able to analyze large amount of data with efficiency, accuracy, and speed. So it seems like AI can be a solution to the needs of cybersecurity. A paper, early paper from 2013, already identified a few applications where AI and machine learning has been used in the domain of cybersecurity, namely intrusion detection systems have seen a good use of AI techniques like anomaly detection, and supervised learning techniques have been used. Web application security has been explored using AI, and a big domain is malware analysis, where AI already in 2013, AI assisted a lot. Furthermore, cyber physical systems have seen beneficial uses also to prevent false data injections and detection of previously unseen intrusions, which are generally regarded as very difficult problems for traditional methods. Then a recent paper from 2020 added to the previous list mobile malware detection, considering that the amount of mobile devices is increasing. There's a huge need to secure those systems as well. So it has been investigated recently. The paper, by the way, is based on several case studies and review paper. It demonstrates how it looks at various domains where AI has been used within cybersecurity. Phishing and spam detection has been growing interest, and many applications have been successfully developed for these applications. And a few examples show that APT's, advanced persistent threats, can be countered by using artificial intelligence, and domain names generated by other AI systems can be detected efficiently, which would be also impossible using human analysts. Other recent papers focused on topics which have emerged lately and influence societies at large. So social media is plagued by various problems, but what has been developed, what has been what investigated, is the detection of various kinds of bots and fake accounts which are operated by some adversaries. So methods were developed to identify bot networks, and fake news detection has been explored by using AI methods. Also, it is predicted that digital forensics can hugely benefit from AI techniques, since it's one of the most computationally and data intensive areas of cybersecurity, where human analysis is beyond feasibility. So the amount of data that forensics has to go through is huge, especially stored on servers, and AI can assist. So these are more like emerging fields, currently emerging fields. However, there are some challenges which limit the usability or the usefulness of AIs in cybersecurity. The most often mentioned problem is that these sophisticated machine learning systems are essentially black boxes. So they are not transparent, and humans do not actually understand why a decision was made by the system, which makes it difficult to audit these systems. And it's important to understand how the system arrived at a certain decision if we want to trust and rely on the predictions of the system. Also, AI systems are very expensive in terms of time and computational power. Also, they require expertise and certain domain knowledge. Another problem is that these narrow AI systems are generally only good for a certain task for which they were developed, and there's a lack of transferability between tasks. Other problems mentioned in the literature include lack of useful big data sets, which can be used to train the systems and compare results. There's a potential for high false alarm rates, which is not very useful for real-world operations. And another big issue is that these AI systems are vulnerable themselves for when adversarial learning is considered, or the presence of adversarials in the learning. So moving on to how the attackers are using AI for their benefit, it's been said that AI can successfully augment attack capabilities by increasing the speed and success rate of attacks, and it can also automate certain kind of attacks. So interestingly, the research results are much less mature in this domain, it seems that there's a lot more uncertainty regarding the adversarial uses of AI. But there are some results which show that already in 2016, DARPA again had a challenge in which AI systems were trained, and it was demonstrated that they can automate the vulnerability discovery, and they can also patch vulnerabilities found in their own system or in the defender system. The problem is that AI can learn and replicate the behavior of legitimate users. AI was used to break several captcha systems which relied on human performance for object recognition. Demonstrations have shown that better dictionary attacks can be conducted, so the AI system can learn patterns in the passwords and generate new potential passwords. Many biometric authentication systems are vulnerable, since AI can now generate new voice samples from previous real world sample, which also transfers to other modalities like fingerprints and faces, as we have seen in the previous in one of the previous slides. Those AI generated faces can be used to break biometric systems. And a big threat is that AI can improve ransomware by adding adaptive capabilities. And there are several applications that have seen sophisticated attacks like gambling and gaming systems. Auction sites are particularly good targets. Social bots can improve spear phishing attacks on various social media sites. And blackmail may rise by AI-generated images and videos, and probably the list can go on. It only depends on the creativity of the attackers. And yeah, there's not so many papers describing the attacker capabilities using AI, but there's already a lot to worry about. A lot of research has been conducted to identify vulnerabilities in the AI system themselves. So here they are not used as a way of attacking or a method of attack. They are the targets of attacks. And there's the fundamental problem is that AI systems were not designed with adversaries in mind. So AI systems have some assumption about the data and the model which they develop, and these do not assume adversaries. However, several researchers have shown that the systems are vulnerable and their decision can be subverted. So in this example, for example, the classifier takes an image and outputs a prediction about what's on the picture, and it identifies the panda. However, if attackers add specifically crafted noise to the picture, it creates another picture which looks very similar to human observers, but this classifier outputs very different prediction with a very high confidence that the picture contains something else. Another paper showed how the machine learning pipeline is vulnerable at each stage. So the pipeline can be attacked at the training phase or testing phase or even the deployment phase, and there are various assumptions about the capabilities of the attackers. So in case of white box attacks, it assumes a strong, powerful adversary who has perfect knowledge of the models and the parameters, where in case of black box attacks, the adversary has no knowledge of the internal workings of the machine learning system, but he's able to explore and probe what the system outputs given a certain input. The first paper from 2011 was introduced the idea of adversarial learning, which is the design of machine learning algorithms that can resist sophisticated attacks, such as the one we have seen with the Panda. And it was the first paper to give a taxonomy of various attacks. So it connected machine learning objectives with the traditional security terminology like integrity, availability, and privacy in this case. And to see a few examples, DNN, a deep neural network, is a very popular and very powerful network which can give predictions about the content of images, for example. And this paper demonstrated how an evolutionary algorithm can be used to generate pictures which are unrecognizable by humans. Nevertheless, when fed into the neural network, it will provide very high confidence predictions about garbage, basically, but it will assume that something, a real world object is present in the pictures. So this one was a very influential attack. And as an example of a black box attack, this paper showed how, without much knowledge of the machine learning systems working, pictures can be modified and created to cause misclassifications. So in the first row, we can see the original samples to which the AI system gives predictions, and they are the correct predictions. And introducing some adversarial modifications, these pictures, in many cases, they look like they are not modified to human observers, but in each case, a wrong prediction is given by the classifier, which has huge consequences for applications relying on these AI systems. So in a white box attack, it's a stronger assumption about the capabilities of the adversary. It assumes that he has access to the model and the parameters, so everything about the AI system is known for the adversary. But in this paper, the researchers presented a way to modify real world objects in such a way that the classifier, which can be a self-driving car, for example, misclassifies. So in this case, they put stickers on stop signs, which people might not be suspicious about. However, the system, when observing these from various distance and various driving conditions they simulated, it thinks that it's a speed limit sign, so it might accelerate instead of stopping in a intersection. And unfortunately, these problems also transfer to cybersecurity systems. So there's one paper which reviewed existing case studies, and it's based on 11 malware and 9 intrusion detection studies, concluded that they are also vulnerable to adversarial learning or adversarial modification of the learning process. It showed which methods were most vulnerable and least vulnerable to these attacks. It was concluded that almost all work uses the same data set, which is a limitation, and it reduces the real world applicability maybe. And it was concluded that adversarial training is the most efficient defense, which is to include adversarial samples already in the training phase on purpose, so that the system becomes more robust in this way. Other potential uses for advanced learning were identified in this early paper, and they said that people can expect attacks and should implement adversarial learning in cases where business case can be identified. So a potential for monetary gain is present. So online advertising, plagiarism detection, copyright enforcement, computer vision system, and sentiment analysis are the main domains which they predicted that will be of high value for the attackers and need to be protected in the future. And the fourth domain is related to AI safety, as it's called in the literature. It's based on the expectation that the frequency and seriousness of undesirable events will increase as AIs become more capable and more widespread. And this can be due to malicious design, so explicit malicious intent by the designer, or due to side effects of poor decisions. And this paper, whose author defines a co-author as a spell checker, lists several famous examples where AI system behaved differently than what the intention was. So AI system caused huge market crash already. One system designed to predict recidivism acted racists, so bias can be introduced in AI systems. Any AI system is just as good as the data that is fed into it, and human biases might creep into the systems as well. There was already a deadly accident caused by a self-driving car or more already since 2016. And there's a famous event when Microsoft developed a chatbot which turned very abusive, verbally abusive, and they had to shut it down because it was interacting with the general audience, and it quickly picked up things which were not very good for the reputation of the company. On the picture, we can see another interesting behavior exhibited by intelligence systems. It is referred to as reward hacking. And in this case, an intelligent agent can find a way to maximize its utility, which is a perfectly legal move from its side. However, the intention is completely different from the intention of the designer. So in this case, the AI had to play a computer game, but it found a loophole or a shortcut to maximize its utility by collecting these pop-ups instead of racing with the others and going through the race course as it was expected. So these might increase in the future, and some people should be prepared to look for such behavior. And in these cases, the AI system itself is can be adversarial unexpectedly. So in conclusion, we can say that AI definitely complicates matters in cybersecurity. It has demonstrated great impact, positive impact in several domains. So it's cybersecurity would benefit. That would be useful. And there's a huge need in cybersecurity to prepare against increasingly sophisticated and quickly evolving adversaries. Several applications, AI applications, are already implemented, and adversaries are also making great use of making more adaptive attacks. However, knowledge is a bit more restricted in this area. AI is expected to contribute more to security, but we need to overcome several challenges in order so that we can trust AI systems in security and in other critical domains, like a lack of transparency and difficulty of auditing the inherent vulnerabilities of these systems and undesirable side effects and surprising behaviors shown by the systems. Papers have said that some knowledge collected from the security domain can be useful and can be utilized in case of AI systems, especially in AI systems that will modify their physical environment and make decisions that impact human lives. So that's that. I hope it was a useful and interesting snapshot of the literature. Thank you for your attention.